Question number 9. Sketch a charge discharge cycle for a capacitor indicating both voltage and current. Okay, so we've got our voltage graph here and we've got our current graph here. So this is our charging circuit, and when we close this circuit, we have a build-up of charge. So we have a whole bunch of pluses come onto this plate here, okay, and a whole bunch of negative charges come here. So initially the current flows out of the power supply and onto the plates of the capacitor. Initially there's a high current because there's no impedance to the flow, but as the charge begins to build up here, these charges repel each other. There's a big electric field stored here, and the current begins to slow down. So what we see is initially there's a peak current which decays at 63% every time constant. After 5 time constants it's pretty much no current, and initially there was no voltage across the capacitor, but as the charges begin to build it gains voltage. Okay, the voltage goes up, and up to 5 time constants is essentially equal to the supply voltage. For the discharging circuit, you notice that there's no power supply. Okay, the charged capacitor essentially acts as the power supply. So when the switch is closed, conventional current will go from positive to negative through the resistor. Okay, so initially there'll be a full voltage here, and that voltage will decrease, and that's what we see up here. So initially have a full voltage, and it'll decrease by 63% every time constant. After 5 time constants, there'll be essentially no voltage left across the capacitor. It'll all have been used through the resistor. Okay, in the circuit you notice that the conventional current flowed onto the positive plate. In this case it flows off the positive plate, so the current's actually going in the opposite direction. Okay, and initially there's the strongest electric field, so strongest opposition, and the current will flow at a maximum here. Okay, so we've got a maximum current here flowing, and eventually that current will decrease. In the charging, it was positive, so it went from the positive plate on, and when it's discharging, it's from the positive plate off. Okay, that's why the currents are in opposite. Initially we have no voltage here when the charging, and it builds up. Initially we have a maximum voltage here and it decreases, hence why we get these two looking curves.